Hello and welcome, phenomenal fans. I've been wanting for a long time to make this video and I'm excited. I want to talk about how to get oxygen into the human body. This is critically important for you or I. And I want to tell you kind of a little bit of a goofball story. This last weekend was our county fair. It's the Nevada County Fair, and we have a blast every year. Well, there was this new thing to do, I guess you'd call it a ride, but it wasn't really a ride. It was a big basin of water. It was about 30 feet wide by maybe 60, 70 feet long. It was about a foot deep. And they have these big blow-up, you call it a hamster ball. It's a big blow-up inflatable ball where you unzip it and they let all the air out of it. You climb inside and then they blow it up and then zip it. And so you're in the middle of this big blow-up ball and then they push you out in the water. And there's all kinds of splay. Of course, you can't really get any traction, so you're falling and you're splashing and you're bumping into people and it's a good time. So my kids wanted to do it, so they said, hey, you do it too. Okay, I'll do it too. So we wait in line. They get in, and they're out there splashing around. Well, another one person was done, so that was my hamster ball I'm going to get inside of. They unzip it. The little kid, he climbs out. I climb inside. But by the time I climbed inside, only about half of the air was deflated. In other words, all the air wasn't changed. And so I climb inside. The guy puts a big air hose in, fills it up with air nice and tight, zip, and give me a push, and there we are, flopping in the water and really working, because of course you have no balance and you can't stand up. So I figured the best way is just to jump and do a big flop. Well, you do a jump and a flop and a jump and a flop, and pretty soon you're tired. And, so then you just lay down and rest because you're floating in the water. And then, so I get back up and I'm trying to chase my kids and trying to knock into people and stuff. And then I lay down and went, I can't breathe. There's like no air in here. And I'm not a panicky person and I'm not a claustrophobic person, but I'm thinking, I can't breathe. And I tried getting up and running again, and then it was desperate. It was just absolutely desperate. So I laid down and I signaled, I got to get out of here. Get me out. And I'm looking at that zipper and I'm thinking, do I want to cause a scene? Do I want to unzip it from the inside and have this whole thing deflate while I'm out in the middle? So it took about a couple minutes, and I just laid down flat, and I felt desperate because there was no air. I huffed it up. They told me when I got out, well, there's 45 minutes of air in there. You should be fine. Well, I'm bigger than a kid, and all the air wasn't exchanged before I got in the first place. It sounds like a lawsuit waiting to happen to me. But I made it out, I'm alive, and now I have the unique privilege of knowing what it feels like to run out of air. And I don't want to go back. You see, in our world, we're running out of air. Now, I don't mean to be like doom and gloom because we're going to be fine, but the fact is that back in the prehistoric age, oxygen levels on Earth were almost 50% higher. Now, I don't even know if a human being could live at 50% higher oxygen, but if we could, our immune system, man, it would be hot. We would have energy, our blood would be like red. It would be so red it's ridiculous. We virtually, in my opinion anyway, virtually couldn't get an infection because your immune system would be so hot because with all that oxygen is alkalinity. Our endurance would be, everything. We would heal faster, we would be smarter, everything if oxygen levels were that much higher. So the question is, how can you get alkalinity or oxygen into the human body? And you have to understand, alkalinity is oxygen. They're one and the same. I'll explain that a little better in a second. Alkalinity and oxygen, they are one and the same. It's the exact same thing. So, I want to point this out, that raw alkalinity and raw oxygen are not stable at higher concentrations. Now, what do I mean by that? If you had a hose with oxygen coming out of it, obviously it's going to come out, it's going to dissipate in the air and not be stable because it's going to neutralize with the air around it. In other words, you might raise the entire oxygen level of a room, but it's not going to be stable. Same thing is true with alkalinity. Alkalinity, if at high enough proportions, will actually use the air to neutralize itself. In other words, they both are looking to be neutralized, so at higher concentrations. Anyway, we're going to go through 3 examples. We're going to start with hydrogen peroxide, and then we're going to go to ozone, and then we're going to go to hyperbaric chambers or hyperbaric oxygen chambers, and then see how to get oxygen into the human body. So, good old hydrogen peroxide. The hydrogen peroxide that you and I would think of is probably the brown bottle in our medicine cabinet. Now, that's either 3% or 5% hydrogen peroxide. because hydrogen peroxide in its pure form would eat a hole right through you. The stuff is really, really strong. And of course, even the stuff in the brown bottle in your medicine cabinet, you put it in your mouth, you swish it around, and boom, you got all that foam. Well, that hydrogen peroxide, the reason it makes foam, like let's say for example in your mouth, is because it's finding all of the bacteria in your mouth, between your teeth and on your tongue and everywhere else. It's oxidizing it, it's literally stealing hydrogen from it, and it's liberating the oxygen from this molecule. So what is the molecule? The molecule is H2O2. So there's two hydrogens, but it has two oxygens. Water, of course, is H2O. So with water, you have a big oxygen and two hydrogens. This guy is a little bit different, and it's not stable. There's an extra oxygen. So for example here, this would be a hydrogen, oxygen, oxygen, hydrogen. Or hydrogen, oxygen, oxygen, hydrogen. So it has extra electrons, and it wants to be filled. In other words, it'll break the bond, turn back into water, and liberate one of those oxygens, and that's that bubbling and foaming. So the question is can you get hydrogen peroxide in your blood at high enough concentrations or on a regular basis to do you any good? You can. Usually it needs to be injected into the blood, in other words, like through a homeopathic drip or something like that, so that's outside the realm of normal person, especially for every day. And of course you can drink it, but once again, it's kind of hard to drink that much hydrogen peroxide, especially on a regular basis, and you can only go so strong because not much of it actually makes it into your bloodstream. So it will go into your bloodstream, but just not that much, not enough to really do that big a job. You got to drink a lot of it on a regular basis, and it tastes nasty, and a lot of people don't like it, and it's hard to keep up with. So hydrogen peroxide is definitely an option, but it's just hard to get it in there. The next one, of course, is good old ozone. This stuff is cool, but man, it is potent. Ozone is radical, absolutely radical. Ozone is just strictly O3. So in other words, it's three oxygens tied together. And to do this, you actually have to turn the positive valences of the oxygen into negative valences to get it to attach up. And of course, these two oxygens, there's two free electrons, and man, they want to come off just like that. They want to be liberated because this thing is very, very unstable. But ozone is beautiful. Ozone can be used for so many things. Ozone is looking to oxidize almost anything. Maybe you have, maybe you haven't seen ozone be used in a clinical setting. In other words, like a doctor's office. What they do is there's a small machine that sits and makes ozone, and so it literally puts the ozone into water, and then they draw a vial of your blood, and they mix the two together, and when they mix it and shake it, the blood turns bright, bright red. It's really cool looking. Bright red, and then they inject it back into your vein. And so what they've just done is they've injected this massive dose of oxygen, or these free radical oxygens, into your blood, and they're going to go and they're going to scavenge, and they're going to find things. It's wonderful. Ozone therapy is fantastic, but of course it's outside the reach of most people. You certainly can't go do it every day, or you could, I guess, if you're wealthy, but go sit down and go get ozone therapy every day. I mean, it's limited in what it will do, but it is a wonderful thing. The other thing, as far as breathing ozone, I don't know of any benefits to breathing ozone. It clears the air is cleaner. A lot of people say that it raises oxygen levels. I've owned ozone machines. I know the ozone smell. I know there's a lot of other things you can do with ozone, but I've never really seen any clinical data, and I could be totally wrong on this, but to be able to actually raise oxygen levels, because as soon as that ozone comes out, it's going to scavenge in the air and neutralize very, very quickly. So it may raise the oxygen levels some. Actually, I personally kind of really like the smell. So anyway, breathing it might be good, but I'm not really sure. The last one, a hyperbaric chamber or hyperbaric oxygen chamber. I see you can't see this picture very well. This was a picture of a hyperbaric chamber, and it's basically, this was one I found online. It was a portable hyperbaric chamber. Starts anywhere between $5,000 to $15,000. And what it is the oxygen levels are raised higher, and then they actually put pressure. In other words, you're in a pressurized environment, much higher than even at sea level, with higher amounts of oxygen. And what happens is it literally forces oxygen into your blood. In other words, the net result is exactly the same. Oxygen levels in the body are higher. I remember seeing in the tabloids years ago, Michael Jackson, pictures of him, I don't even know if it's true, sleeping in a hyperbaric chamber. I think it's a great idea. If you owned one, I'd sleep in it. That'd be fantastic. So you're getting higher levels of oxygen in your body all the time, and you climb in there, you get used to it after a while. It's fantastic, but outside the reach of most people. So there's another question. What is alkaline water, or what is acid water? Like I said before, alkalinity and oxygen are the exact same thing. Therefore, acidity and lack of oxygen are the exact same thing. In other words, in my bubble, when I was laying there and I couldn't breathe, you could say that the air, I had acidified the air in there, or I had taken the oxygen out of the air. It's the exact same thing. There's more carbon dioxide in the air. There's less oxygen for my lungs to be able to pick up and put into my body, and given enough times, I would have completely run out of oxygen. So, if you're going to put alkalinity in water, or if you're going to put acidity in water, what does that look like? What is it? Let's start with a regular water molecule. Once again, you got a big oxygen, and you've got two hydrogens. This isn't accurate, by the way, because hydrogens are one of the smallest molecules there are. They're little tiny guys. But for the sake of this picture, we blew them up nice and big. An oxygen has what's called two valences. This is where other molecules attach to it, and these are positive electrons. In other words, they're a free electron ready to give away. So when you attach two hydrogens to it, they're bound because, of course, hydrogen has a negative, or it's missing an electron. So a water molecule is stable. Everybody's happy because hydrogens are negative, oxygen is positive, they glom together, everybody's happy. If you had water, now once again, this is for illustration purposes only because it's totally inaccurate, but the idea is if you had an oxygen floating around, a water floating around, so you have an oxygen, two hydrogens, if you have simply an abundance of extra hydrogens, that would be acidic water. In other words, the pH of the water would be lower. It means there's more acid or hydrogens in that water. And the opposite is true as well. If you had stabilized water, and then you have the occasional oxygen, well, that would be very alkaline water. In other words, you're missing hydrogens. Okay, well, that begs the question, what is phenomenal? Now, I'm not making this just as a pitch for phenomenal, because this is the way it is. Phenomenal, if we start back with the water, we have oxygen, two hydrogens. Once again, the real key and the thing is it starts with an oxygen, because an oxygen wants hydrogen, it wants acidity. And phenomenal is an oxygen, it has one hydrogen, but it's missing this one. It's called hydroxide, or H1O1. In other words, it's one hydrogen, H1, one oxygen, which is O1, and it's missing this other one. Well, what does that mean to you and I? It means that it's dying to find acidity. It's dying to glom onto acidity literally from your body. And water starts being absorbed in your mouth, in your throat, in your esophagus on the way down, and then lastly in your stomach. And even if it dissolves stomach acid, your body has to go back out into your blood, get hydrogen to make more hydrochloric acid for your stomach acid. So even if it neutralizes stomach acid, the net result is the same, loss of hydrogen. Or, look at it the other way, if you lose hydrogen, there's more room for oxygen. So once this guy binds onto a hydrogen, it becomes water. And that's the beautiful part, is that it wants to turn back into water, and water is totally harmless. So that's why, I don't know if you've ever drank Phenomenal, but a lot of people, when you start drinking Phenomenal, you drink the Phenomenal and then you gotta pee. And it's like, man, I gotta go now. And the reason why is because it is bound with hydrogen and is turned back into water, and you gotta go. But it's literally flushing acidity from the body. And the beauty is, when it's gone, it's gone. Whereas like with ozone, those oxygens, they'll go out and they'll grab hydrogens, but we very quickly breathe them out. In other words, if you had a large enough dose of ozone, could you hold your breath for longer? Maybe. But our body's natural functioning will use up putting extra oxygen in the blood. Whereas with Phenomenal, you're binding the acidity, you're giving your body a chance to dump and get rid of acidity, and once it's gone, it's gone. It turned into water, and you left it behind. So cool. So that's what phenomenal is. Phenomenal is a molecule. Once again, it's not stable in the sense that it will neutralize itself if you leave it open to the air, or it will neutralize itself when you drink it. It's going to turn back into normal, neutral pH water when you drink it. Very cool. Very awesome. That's phenomenal. H1O1 hydroxide, whatever you want to call it. But it is beautiful. It's wonderful. It's one of the fastest ways to get oxygen and alkalinity back in your body. So that's it. That's what phenomenal is. And that's also hydrogen peroxide, ozone, and hyperbaric chambers. Have a fantastic day.